Welcome to all students. This class is class 12 of mathematics and topic is function. We have been read about inverse function in previous class. In this class, I am going to read some result on invertible function. Then here show that three results on the invertible function. According to definition of invertible function or inverse function, every function which is 1 and onto, then that function is called invertible function. Means if an inverse can be exist, or in the other word, the inverse of any function can be exist if that function is 1 and onto. Means only 1 onto function can be exist as inverse. Means 1 onto function is invertible function. Here the first result is invertible function has an unique inverse. Means every invertible function has unique inverse. Means there is no other than inverse exist about this function. Second is if f is a function. Suppose that f is a function, then f inverse whole inverse. It shows that the inverse of inverse means inverse of the inverse function. That's a function. If that function means initial function, means the function f can exist after inverse of their inverse. It is called f inverse whole inverse is equal to f. And third result is if f and g are two functions and their composition g of f is defined, and inverse of g of f gets as f inverse operation g inverse. Means g of f inverse reverse the composition of the function. Now we prove some result. I am going to prove result first. Suppose that for invertible function f of g, suppose that two functions are given. If first function is f and second function is g. Suppose that if possible, assume two inverse there are two inverse of the function is f and g. Suppose that any function has two inverse. First inverse is f and second inverse is g. Of any function in first inverse g and second inverse h of any function f. Means f has two inverse. First inverse is g and second inverse h. Then composition of f and g and composition of f and h will be same digit, will be same element. If composition of f with both the functions are same, then that inverse is also equal. Inverse is also same. Now we prove about their composition. Exist their composition. First composition is taken as FOG. Suppose that FOG and FOG is equal to IG. If g is inverse of the first function, then their composition with function f will be an identity function, and g of f is also identity function. means composition of the function with their inverse is identity function. We have been read from definition of the invertible function or inverse function. Now, therefore, we can say that FOG will be equal to GOF, and hence FOG of element Y will be equal to GOF of element Y. From definition of composition of function, FOGY is represented as function of GY is equal to composition of OG and HOG. OG is not possible. G and H are unity function, which is inverse of this function. Then GOF will be equal to GOH. It is possible. GOF will be equal to GOF is equal to HOF. This implies, and it is equal to IB, means it is inverse function, invertible function. The composition of a function with inverse function is an identity function, and both composition will be also an identity function. Then GOF Y will be equal to HOF Y. This implies, according to definition of composition of the function, we get G of Fy will be equal to H of Fy. Since Fy, the value of Fy and value of Fy will be same in the both composition. Suppose that Fy is equal to Z. This implies GZ equal to HZ. We observe that the function G and H are same. We assume that in the previous example, G and H are inverse of the two functions, means G and H are inverse of function F. G and H are two inverse of the function F. Therefore, GH and FZ are equal, means GZ is equal to FZ, means image of any element Z for the function G and image of the element Z for the function H are same. Therefore, G and H are the same function. Hence, G and H are same function, and G and H are inverse of function. There are two inverse G and H, and G and H both are equal. Hence, only one inverse function can be exist of any function. It is proved from this example. Similarly, hence there is only one inverse can be exist of the function. Hence inverse of the function is unique. It is proved as result. Similarly, we can prove some other two results. Now we see about some examples, some problems related with the inverse of the function. First example, given that first example, suppose that function is defined as n to y, where n is natural number and y is any other set, and function is defined as fx is equal to 4x square plus 12x plus 15, and y equal to range of f, where y is the range of the function. Means the function defined between two sets. First set is natural number n and second set is y. Y is any set and which is codomain of the function. Means y is the codomain of the function f. Now we have to prove that this function is invertible function. Means there can exist inverse of this function. Now we have to check the function for 1 1 and into 1 1 and onto. If this function is 1 1 and onto, then we can say that the function is inverse. Its function is inverse can be exist. First of all, we check the function for 1 1 function. So that the function is invertible function. To check for 1 1 function. If the function is 1 1 function, then every two element belongs to natural number or this, and such that these two elements are equal to each other. Means suppose that two elements x1 and x2, which is element of natural number, means two natural number x1 and x2 are taken from the domain of the function, and suppose that x1 and x2 are equal or not equal, but if fx1 and fx2 are equal, or any two elements x1 and x2, or two elements x1 and x2, which is both are element of natural number, means domain of the function, and if x1 is equal to fx2. If fx1 is equal to fx2, then we can put the value of x1 in the place of x in the function f. So fx1 will be represented as 4x1 square plus 12x1 plus 15 is also equal to 4x1 square x2 square plus 12x2 plus 15. 15 and 15 can be cancelled, and 4x1 square minus 4x2 square can be taken on one side. 12x1 minus 12x2, and other side will be 0. And this implies we can common from first two terms. 4 is common from first two terms, therefore x1 square minus x2 square plus x12 is common from the second two term. 12 is common, therefore x1 minus x2 equal to 0. We can factorize this expression. X1 square minus x2 square, its factor is x1 plus x2 or into x1 minus x2. There is 2 factor plus 12 x1 minus x2. We see that x1 minus x2 is the common factor in the both two terms. Now we can common from the both two terms x1 minus x2. Hence, we find that 4 into x1 plus x2 plus 12 is equal to 0. Now, x1 minus x2 has taken in one side and other factor can be bring from the at the second side. Then the 0 by 4 into x1 plus x2 plus 12. This implies x1 minus x2 is equal to 0. Therefore, x1 is equal to x2. Or if x1 is equal to x2, we get x1 is equal to x2. Then, hence, the function is 1, 1 function. Now, we have to prove the given function is onto function. For onto function, we take fx as y. Let fx equal to y. This implies y is equal to 4x square plus 12x plus 15. This implies y is equal to 4x square. 4x square is written in the form of 2x square plus 12x can be written in the form of 2 into 2x into 3 plus 15. This implies y is equal to 2x whole square plus 2 into 2x into 3. We can add 3 square and subtract 3 square in the expression. This implies y will be equal to 2x plus 3 whole square plus 15 minus 9. This implies y is equal to 2x plus 3 whole square plus 6. This implies y minus 6 is equal to 2x plus 3 whole square. This implies we can replace the square, then root under y minus 6 will be equal to 2x plus 3. Hence, y minus 6 whole root minus 3 is equal to 2x. Then x will be equal to root under y minus 6 minus 3 upon 2. From this expression, y is real for every value which is less than 6, which is less than 6. Hence, we can show that we can say that y is the range of the function. From the question, y is the range of the function means y have only that element which is corresponding value of x lies in the y. Then for every y belongs to range, y belongs to y, the x is real. Then the function is onto function. Hence, the given function is 1, 1 onto. Therefore, this is invertible function. If the function is invertible, then we can exist inverse of the function, and the inverse of the function is taken as the variable y, and it is f inverse x is equal to f inverse y is equal to root under y minus 6 minus 3 upon 2. It is the inverse of the given function. Similarly, we can exist inverse of any other function which is 1, 1 and onto function. Means First of all, we have to check for the function 1 1 onto or not 1 1 onto. If the function is 1 1 but not onto, then the inverse cannot be exist. If the function is many 1 and onto, then after we cannot exist the inverse of the function.